There is a muscle inside your leg right now that most doctors never mention, most patients have never heard of, and most fitness trainers completely ignore. And yet, according to research out of the University of Houston, switching it on for 15 minutes after a meal can cut your blood sugar spike almost in half. Not with a pill, not with a diet, not with a single minute at the gym. Just one quiet movement, done while sitting in a chair. Once you understand what this muscle does and why it does it so well, you will never look at that sluggish, foggy, I need a nap feeling after lunch the same way again, because that feeling was never really about getting older, and it was never really about willpower. It was about chemistry, and chemistry can be changed. Let's get into exactly how. To understand why this works, we first have to understand something most people walk around their entire lives never learning: what actually happens inside your body in the hour or two after you eat. Because here's the truth: the food itself is rarely the real problem. It's what your body is forced to do with that food in the minutes that follow, and whether you give it any help or leave it to handle everything alone. So before we get to the muscle, let's talk about the chemistry it's solving. Every time you eat something made of carbohydrate, bread, rice, pasta, a banana, even a sweet potato, your digestive system breaks it down into a simple sugar called glucose. That glucose then enters your bloodstream. This is not a flaw in the system. This is the system working exactly as designed. Glucose is fuel. It's the energy currency your cells run on. Your heart needs it to keep beating. Your muscles need it to move. And your brain needs it almost more than anything else in your entire body. In fact, your brain is so dependent on a steady glucose supply that if it drops too low for even a few minutes, you lose your ability to think clearly. So glucose itself is not the villain in this story. You cannot live without it, and you wouldn't want to. The actual problem starts somewhere else entirely, in the speed and the size of the wave. Here's a way to picture it. Imagine a quiet river feeding into a lake. If the river flows steadily, the lake stays calm. The water level barely moves. Everything is in balance. Now imagine a flash flood. Suddenly, far more water arrives than the lake's outlets can drain away in time. The water rises fast. It has to go somewhere, and fast. That's roughly what happens inside your blood vessels when a large dose of fast-digesting carbohydrate hits your system all at once. Your blood glucose rises quickly, sometimes very quickly, and your body has to respond immediately. The organ responsible for that response sits quietly behind your stomach. It's called the pancreas, and the moment it senses that surge, it releases a hormone called insulin. Think of insulin as a dispatcher standing at the edge of that flooded lake, directing water where it needs to go. Some of it gets sent to your muscles to be used as immediate fuel. A good portion gets sent to your liver, where it's packed away into a storage form called glycogen, essentially your body's emergency reserve tank. But reserve tanks have limits. If your muscles are already fueled and your liver's glycogen storage is already full, and let's be honest, for most adults sitting at a desk or on a couch after a meal, that's often exactly the case. Your body still has glucose left over that has to go somewhere, so it does the only thing left available to it. It converts that extra glucose into fat and tucks it away into your fat cells. And once glucose has been converted and stored that way, getting it back out again is a slow, difficult process, nothing like the speed at which it went in. Meanwhile, your pancreas, having released a large burst of insulin to handle that flood, has often done its job a little too well. Blood sugar doesn't just come back down to baseline. It frequently overshoots and dips below where it started before you even picked up your fork. That dip is where the story most people know all too well actually begins. Your brain, which depends on a steady glucose supply more than almost any organ in your body, notices that dip almost instantly. And because your brain's number one priority is always self-preservation, it treats a falling glucose level as an emergency, even when there's nothing actually dangerous happening. It sends out urgent signals. Energy reserves are dropping. Find more fuel. Find it now. That's the moment a heavy, almost irresistible tiredness rolls in. Your thoughts slow down. Your eyelids feel like they have weights attached to them. And somewhere underneath all of that fog, a very specific craving shows up. Not for protein, not for a salad, for something sweet. Immediately. This is the part I really want you to hear clearly. because so many people carry guilt about it for years. That craving has nothing to do with weak willpower, and it has nothing to do with your character. It is pure biology. Your brain is doing exactly the job evolution gave it, protecting itself from running out of fuel by demanding more, right now, by any means necessary. Sugar went up fast. Sugar came down fast. And now your brain has shifted into a kind of energy conservation mode, dimming down everything that isn't strictly necessary so it can protect its core functions. That's the real explanation behind the wall so many people hit in the middle of the afternoon. Let me tell you about a woman I'll call Patricia. She's 47, she teaches high school history, and by every measure, she's sharp. Her mornings are productive. Her first 3 class periods go smoothly. But almost every single afternoon, somewhere around 2 o'clock, something shifts. Her thoughts get heavy. The words on the page in front of her seem to blur together. She finds herself reading the same paragraph of a lesson plan 3 times without absorbing it. And like clockwork, she finds an excuse to walk past the vending machine in the staff lounge. And just as reliably, she walks away from it holding a candy bar. For years, Patricia told herself this was just who she was. I've always had a sweet tooth. I just don't have discipline in the afternoon. She carried a quiet sense of shame about it, the kind that builds up slowly over years without anyone ever saying it out loud. But Patricia wasn't lacking discipline. Patricia's body was running the exact biochemical sequence we just walked through, day after day after day. Lunch sent her glucose up sharply. Her pancreas answered with a large insulin response. Her glucose came back down, overshot, and dipped. Her brain panicked and demanded sugar. The candy bar pushed glucose back up, and a couple of hours later, the entire cycle repeated itself in miniature. By the time she got home in the evening, Patricia often felt completely drained, even on days where her actual workload had been light. She wasn't tired from teaching. She was tired from riding a blood sugar roller coaster that nobody had ever explained to her. Have you ever noticed a pattern like that in your own afternoons? If you have, you're far from alone. This is one of the most common patterns in modern primary care, and it almost never gets traced back to its real cause. Here's the part that deserves real attention. Every single one of those spikes and crashes costs your body something. Every time glucose rises sharply, your pancreas has to respond with another burst of insulin. Once, twice, a few hundred times, a few thousand times, across years. And your pancreas is not a machine with infinite capacity. It has a working life, and constant demand wears on it. At first, it keeps up effortlessly. Over time, it starts to lag, and eventually, something else begins to happen that's even more important to understand. Your cells start to stop listening to insulin signal as well as they used to. This condition has a name: insulin resistance. In plain terms, it means there's still plenty of insulin circulating in your blood, doing its job, knocking on the door of your cells. But the lock on that door has started to stick. The key still exists. The lock just doesn't turn as easily anymore. So your pancreas compensates the only way it knows how, by producing even more insulin to force the same amount of glucose through a door that's becoming harder to open. More insulin, working harder, for less and less in return, year after year. Here's what makes this especially tricky. For a long stretch of time, your standard blood work can come back looking completely normal. No diagnosis, no red flag on the lab report. And yet you might be living with fatigue that doesn't make sense for how much sleep you're getting. Stubborn fat that's settling around your midsection no matter what you do. Cravings that simply will not loosen their grip. It's easy to live with all of that for years and assume there's nothing concrete to point to, because on paper, nothing is officially wrong. But this exact window, the one where nothing has technically crossed a diagnostic line yet, happens to be the single easiest moment to turn the entire trajectory around. Let me tell you about a man I'll call Robert. He's 54, and he went to see his doctor for something that had nothing to do with blood sugar at all, nagging pain in his knee from years of recreational basketball. But while he was there, almost as a passing comment, he mentioned that he'd been unusually hungry for the past few years. Hungry again barely an hour after finishing a full meal. His doctor, recognizing the pattern, ordered some blood work. Robert's fasting glucose came back sitting right at the very top of the normal range. Not diabetes, not even officially labeled prediabetes. But to a clinician who has seen this pattern hundreds of times, that number tells a very specific story. The pancreas is working near the edge of its capacity, and the reserve is starting to shrink. Nobody had caught it earlier because on the surface everything had looked technically fine. If this whole process is left to continue unchecked, insulin resistance slides toward prediabetes. Prediabetes, left alone, slides toward type 2 diabetes. And once type 2 diabetes is established, the downstream complications are well documented in medical literature. Effects on blood vessels, on eyesight, on kidney function, on the body's ability to heal wounds, particularly in the feet. I'm not telling you this to frighten you. I'm telling you this because the next part of this video is genuinely good news. While your numbers are still sitting in a normal or borderline range, this entire trajectory can often be slowed, stopped, or in many cases meaningfully reversed. And the tool that does it is something you already own. That tool is your own muscle. If this is connecting some dots for you so far, a quick like genuinely helps more people come across this video. Now, let's get into exactly how your muscles pull this off, because the mechanism is honestly fascinating. Inside every one of your muscle cells live tiny structures called mitochondria. You don't need to memorize the word. What matters is what they actually do. They function like small furnaces, pulling glucose out of your bloodstream, burning it, and converting it into usable energy and heat. While a muscle is sitting still, those furnaces run on what amounts to a low pilot light. They barely sip any fuel at all. But the instant that muscle begins to contract, even gently, those furnaces flare up and start pulling in glucose at a dramatically higher rate. Here's the detail that makes this genuinely remarkable. Under normal resting conditions, glucose needs insulin to act like a key, unlocking a door on the surface of the cell called a GLUT4 transporter before it's allowed to enter. No insulin, generally speaking, no entry, but a contracting muscle has access to a separate door entirely, one that doesn't require that key at all. The simple mechanical act of the muscle contracting triggers those same transporters to move to the cell surface on their own, opening a path for glucose to flow directly from the bloodstream into the muscle. Your pancreas barely has to participate. Insulin stays calm. The whole roller coaster sequence we described earlier never even gets started. This is exactly why the 90 minutes or so following a meal represent the single most valuable window of the day for your metabolism. That's when glucose is climbing. That's the precise moment your muscles can intercept it directly, before it has any opportunity to be packed away into fat cells, and before your pancreas is forced into another large insulin response. Before we go further, one honest note. The science behind muscle contraction and glucose control is well established and genuinely solid. But it only delivers lasting benefit if it becomes a consistent habit, not an occasional event. A single walk after a single meal helps with that single meal. A daily pattern of movement after eating gradually reshapes how your entire body manages glucose over time. Your cells become more responsive to insulin. Your muscles become hungrier for sugar by default. Your whole metabolic baseline shifts in a healthier direction. The operative word here is consistency, not intensity. You don't need to push yourself. You need to show up in some small way after most meals. So which muscle handles this job better than almost any other in the human body? It's tucked away on the back of your lower leg, just beneath your knee. There are two main muscles stacked there. The one you can actually see, the muscle that bulges when you rise up onto your toes, is called the gastrocnemius. That's the showy one, the one bodybuilders train. But underneath it, hidden from view, lies a second muscle called the soleus. Most people have genuinely never heard its name. You can't see it in a mirror, and on its own you can barely feel it working. And yet, pound for pound, when it comes to clearing glucose from the bloodstream, nothing else in your body quite matches it. A research team at the University of Houston ran an experiment that genuinely surprised even the scientists conducting it. The findings were published in the peer-reviewed journal iScience in 2022. Researchers had participants sit in a chair and perform one extremely simple repeated movement after eating. Lifting their heels up off the floor while keeping their toes planted, then lowering them back down over and over. People could be working at a laptop, watching television, or sitting in a waiting room. Nothing about their day had to change. The only thing in motion was the back of the foot. The results were striking. The after-meal glucose spike dropped by roughly 52% compared to sitting still. Insulin release dropped by close to 60%. That second figure is the one that really matters, because it tells you the pancreas barely had to get involved at all. The Soleus was pulling glucose out of circulation so efficiently that a large insulin surge simply wasn't necessary. Researchers nicknamed this movement the Soleus push-up, and it's exactly as simple as it sounds. You can try this right now, wherever you happen to be sitting. Plant both feet flat on the floor. Keep your toes pressed down against the ground. Now, slowly lift your heels upward. Then lower them back down. Up, down, at whatever pace feels comfortable. You can do this at your desk while answering emails. You can do it on your couch during a television show. You can do it sitting in a waiting room, and the person next to you will likely never even notice. 10 to 15 minutes of this after a meal appears to be enough to produce a real, measurable difference. I want to introduce you to someone I'll call Daniel, 41, who works remotely from a home office. After hearing about research like this, he started doing a version of the Soleus push-up during conference calls, simply lifting and lowering his heels under his desk while listening in. He told me the most noticeable change wasn't dramatic. It was that the heavy, foggy 2 o'clock slump that used to derail his entire afternoon simply stopped showing up most days. Nothing else in his routine had changed except that one small habit. The Soleus push-up is remarkably efficient, but it isn't the only option. And the more muscle you bring into the picture after a meal, the faster glucose clears from your bloodstream. The first additional tool is simply a short walk. In published research comparing two groups eating an identical meal, the group that took a relaxed 10-minute walk afterward experienced a glucose peak roughly half the size of the group that sat quietly. We're not talking about a treadmill session or an intense workout. 10 minutes, easy pace, anywhere. Outside, around your living room, up and down a hallway. The only requirement is movement instead of stillness. The second tool is the squat, and it works quickly because it recruits some of the largest muscle groups in your entire body, your thighs and your glutes. More muscle mass engaged means more glucose pulled out of circulation per minute. The form is simple. Stand with your feet roughly shoulder-width apart, toes turned slightly outward. Lower yourself down as far as feels comfortable, keeping your back straight and letting your knees track in line with your toes. Push back up. 10 slow, controlled repetitions is plenty. A practical trick many people use is to do a set while the kettle is heating water for after-dinner tea. By the time it clicks off, you've given your glucose somewhere productive to go. The third tool is one almost everyone already does, just at the wrong time. Housework. Most people clean up well before a meal or an hour or more after, once glucose has already been dealt with one way or another. The trick is simply shifting that same activity to right after eating. Roughly 15 minutes of cleaning, washing dishes by hand, wiping counters, sweeping a floor is, in terms of glucose impact, comparable to a 10-minute walk. You're standing, you're moving your arms and legs, and you didn't need any extra motivation, because you were already planning to do it. What I genuinely love about all four of these tools, the Soleus push-up, the short walk, the squats, and the housework, is that none of them require you to restructure your life. No gym membership, no special equipment, no early alarm clock. You simply stop sitting completely motionless for the first 10 or 15 minutes after you eat. And if you truly must sit, then sit, and let your heels do the work for you. Where are you watching this from, by the way? Drop your city or country in the comments below. I always enjoy seeing just how many places this kind of information reaches. There's one more piece of this puzzle worth understanding on its own. How quickly insulin resistance develops and how quickly it can be reversed is heavily influenced by age. After 40, muscle mass naturally begins to decline if it isn't actively maintained, a process doctors refer to as sarcopenia. Less muscle mass means a smaller overall glucose disposal system. A smaller disposal system means more pressure falls on the pancreas to handle the same workload. More pressure on the pancreas means that roller coaster cycle we described earlier becomes louder, more frequent, and harder to ignore. This is precisely why movement after meals tends to matter even more as the years go on, not less. The muscle you maintain in your 40s, 50s, and 60s is doing double duty, supporting your strength and mobility and quietly protecting your metabolic health at the same time. A few questions tend to come up whenever this topic gets discussed, so let's address them directly. Does this replace medication for someone who already has diagnosed diabetes? No. If you're managing diabetes with medication, these movement strategies can be a valuable complement to your treatment plan, but any changes to medication or management should always go through your physician, never a video. Do you need to do all 4 tools every single day? Not necessarily. Even consistently using just one, paired with your largest meal of the day, tends to produce a noticeable shift over a matter of weeks. What if you have a desk job and truly cannot get up after lunch? That's exactly the scenario the Soleus push-up was designed to solve. It requires no standing, no walking, and almost no visible movement at all. In the short term, here's what tends to happen once people start moving in the 15 to 20 minutes after eating. That heavy afternoon fog tends to lift within days. Energy stops collapsing an hour after a meal. And that urgent, almost desperate craving for something sweet gradually loses its grip. In the longer term, something even more meaningful is happening underneath the surface. Every time your muscles handle glucose directly, your pancreas gets a small break. Multiply that break across months and years, and you're looking at the real difference between staying metabolically healthy well into your 60s and 70s versus slowly drifting toward insulin resistance, prediabetes, and eventually type 2 diabetes. So here's what's genuinely worth doing starting today. Pay attention to what you actually do in the 15 to 20 minutes right after you eat. Try the seated heel raise at least once and notice how you feel an hour later. Bring up your fasting glucose number at your next doctor's visit and ask whether a hemoglobin A1C test, which reflects your average blood sugar over roughly the past 3 months, makes sense for your situation. And if you're already taking something like metformin, or considering supplements people sometimes mention such as berberine or magnesium glycinate, those are conversations to have with your own healthcare provider, who knows your full medical history. Not with a video on the internet. Take what's useful here and put it in front of someone qualified to apply it specifically to you. What I hope you take away from all of this is something hopeful, not something heavy. None of this requires perfection. It doesn't require a complete overhaul of how you live. It asks for 15 minutes, a handful of times a week, using muscle you already have, doing something your body already knows how to do. The roller coaster so many people quietly live with for years, the fog, the crash, the cravings, the guilt that comes with all of it, was never really a character flaw. It was unexplained chemistry. And chemistry, once you understand it, becomes something you can actually work with. If today's video gave you something worth holding on to, I'd genuinely appreciate it if you hit subscribe, because content like this is exactly what this channel is built around. Clear, evidence-based explanations of the health topics that actually shape how we feel day to day. I'm Dr. David Aid, and this is where we take the science that usually stays locked away in research journals and turn it into something you can actually use in your own life, starting today. Thank you for spending this time with me. I'll see you in the next one.